Hey everybody, welcome back. This is part 3 of the chapter 5 day 2 notes. So we'll just continue along with the examples. For example 6, we want to evaluate the integral from negative 2 to 3 of the absolute value of 2x. Now, there should, just for notation, there should be a dx there. Because whenever we're taking an integral, we have to know what variable we're taking the integral with respect to, just like with derivatives. So now, as we go to evaluate this, if you tried to type that in your calculator, let's just see what happens. Because sometimes you will have calculators available to you. So if we were to go ahead and plug that into our calculator, we want to integrate from negative 2 to 3 the absolute value. So we can just go ahead and type in the S of 2 times x with respect to x. Hit enter, and the calculator will do that for you. All right, and that's good to know. So we should get an answer of 13. Now, if we were to go and do this by hand, there is something we have to take into account, is there's a sharp turn. So there's really two methods that we can apply. One of them would be to simply use the geometric shapes. So if we want to know the integral from negative 2 to 3, all right, there is this sharp turn at 0. But we're basically finding the area of that triangle and the area of that triangle and adding them together. So we can find it using geometric shapes, and we'll get the exact area when we do that. So for the first triangle, we have 1/2. What's that? The base is 2, and the height is 1, 2, 3, 4. And if we take the second, we have 1, 2, 3. So the base is 3, and the height is 1, 2, 3, 4, 5, 6. So half of 2 is 1. 1 times 4 is 4. Half of 3 is 3/2. Better way to do it is half of 6 is 3. 3 times 3 is 9. And you get that 13. All right. Now, if we're going to take the integral by hand, what we're going to have to do is split it up into two integrals. And we're going to have to evaluate this integral first. So to do that, we're going to have the integral from negative 2 to 0. Now, we're not going to use the absolute value function. To the left of that sharp turn, you basically have a line with a negative slope. So this is going to have the function negative 2x dx. And then on the right-hand side, we're going to integrate from 0 to 3, but now we have a line with a positive slope. And that's going to be positive 2x dx. So essentially what we did is we split, or we wrote that absolute value function as a piecewise function in a way. Less than 0, it's negative 2x. Greater than 0, it's positive 2x. And as you go to integrate that now, this becomes negative x squared, and we're evaluating from negative 2 to 0. Over here, you get positive x squared, and we're evaluating from 0 to 3. So as we go to substitute, you have negative 0 squared minus negative 2 squared. So you got to be careful with all those negative signs. Plus 3 squared minus 0 squared is what's happening there. So that's obviously going to be 0. Now, negative 2 squared is positive 4. Positive 4 times negative 1 is negative 4, and then negative 4 times negative 1 is positive 4. And then we got 3 squared, which is 9, minus 0, and that's where you get 13 as well. So, there are times when you have to, evaluate the integrals individually because of those sharp turns. All right, we're going to go ahead, guys, and continue to take a look at the notes. And as we do that, we're going to be focusing on, different properties of definite integrals that exist. So, for number one, it says the integral from a to b of 1 dx is b minus a. And then also, c times the integral from a to b of 1 dx is c times b minus a. So basically what that is telling us is if we're integrating 1, the integral of 1 would be x. So think about what's happening. The integral of 1 would be x. We're evaluating that from a to b. So it's the upper limit b minus the lower limit a. If it's a constant times 1, then it's just the constant times that interval. So, again, if we applied that same property to this problem, 3 is not 1. So what we would do is we would be thinking about this as 3 times the integral of 2 to 6 of 1 dx. And applying this rule, that's going to be 3 times 6 minus 2, which is 3 times 4, or 12. Now, another way to think about that, and maybe it's almost easier too, is to just do the integral. Because if we wanted to take the integral from 2 to 6 of 3 dx, the integral of 3 is 3x. We're evaluating that from 2 to 6. So that's simply 3 times 6 minus 3 times 2. 3 times 6 is 18. 3 times 2 is 6. And you get 12. Neither way is more right or wrong. It kind of comes down to what you prefer. All right? But when you do take the integral of 1, it's always going to be the upper limit minus the lower limit. If it's the integral of a constant other than 1, then you just take the constant and you multiply by the difference of those intervals. So that comes in handy sometimes. Let's take a look at the next property. So the next property we have says the integral from a to b of c of f of x dx is equal to c times the integral from a to b of f of x dx. And again, whenever you evaluate an integral, if there's a constant, you can always take that constant out. So example 8 says if the integral from 0 to 3 of g of x dx is equal to 9, and we want to evaluate the integral from 0 to 3 of 4 times gx dx, we can apply that property and simply take out the 4. So it'd be 4 times the integral from 0 to 3 of gx dx. And we know that this is equal to 9. So because of that, this is simply 4 times 9, which is 36. So there are definite times where understanding these properties can help you work through these problems. And again, it really depends on what information you're given. Now, for example 3, or not example 3, but the third property, we have the integral from a to b of f of x plus or minus g of x dx. And what this is saying is that we can separate this as the integral from a to b of f of x dx plus or minus the integral from a to b of g of x dx. So the integral of a sum or difference is the sum or difference of the integrals. Now the key is that they have to be on the same interval. That is important that you pay attention to what those limits of integration are, the intervals. All right, so based on that, if we want to apply that to example 9, we have the integral from 1 to 3 of f of x dx being 6. We have the integral from 1 to 3 of g of x being, and again, there should be a dx right there, equaling negative 4. We're trying to evaluate the integral from 1 to 3 of f of x plus 2 times g of x dx. So again, this piece right here is, what you can do, I'll just kind of write this out, is you can think about this as the integral from 1 to 3 of f of x dx plus 2 times the integral from 1 to 3 of g of x dx. And then purely through substitution, the integral from 1 to 3 of f of x dx is 6 plus 2 times the integral from 1 to 3 of g of x was negative 4. So 6 minus 8 is negative 2. And that's how we would answer that question. All right, I think we got time here to at least look at one more property in this video. So the next one, property 4, says the integral from a to a of f of x dx is 0. So what you want to pay attention to here is, if we took the integral of this, it would basically be the antiderivative of f evaluated at a minus the antiderivative of f evaluated at a. And if you take any value and subtract itself, you get 0. The key to this is that the width of your interval is 0. All right? Anytime that happens, the integral is 0. So in this case, we have the integral from 4 to 4. So we can make a little note here. The area is 0 if there is no width of the interval. So without doing any work, we know that this integral is simply 0. All right, I'm going to go one more time. All right, we got a little bit more time in this video. So the next one says the integral from a to b of f of x dx is equal to the negative integral from b to a of f of x dx. So you want to pay attention to what happened here. So the limits of integration switched. They were a to b, now they are b to a. What this property is telling you is that if that happens, if you switch those limits of integration, then you simply get the opposite value. So instead of it being a negative, it would be a positive, or vice versa. So in this particular problem, we know that the integral from 4 to 9 of gx dx is 38/3. We want to evaluate the integral from 9 to 4 of gx dx. So in applying the property, the integral from 9 to 4 of g of x dx is going to equal the opposite of the integral from 4 to 9 of g of x dx. And from the information above, we know that the integral from 4 to 9 is 38/3. So the opposite of 38/3 is negative 38/3, and that would be the answer to the question. Really important that you guys learn these properties because they can be very helpful, one, in understanding what's happening, but two, in being able to solve problems quickly and efficiently. That's going to do it for part 3. Please make sure you guys check out part 4.